Architecture, a field that has evolved over millennia, reflects humanity's aspirations, cultural developments, and technological advancements. From the rudimentary shelters of early humans to the towering skyscrapers of modern cities, architectural discoveries have continually transformed how we live, work, and perceive our environment. If you enjoy this video about architecture, please like, share, and subscribe. At the end of the video, please use the comment section to ask us any questions about architecture. One of the earliest and most fundamental discoveries in architecture is the use of natural materials for construction. Early humans utilized available resources like wood, stone, and mud to create shelters. The discovery of how to shape and stack stones led to the construction of megalithic structures like Stonehenge and the pyramids of Egypt. These ancient monuments not only demonstrate the ingenuity of early architects, but also their understanding of structural principles, such as weight distribution and balance. The invention of the arch and the vault was a significant breakthrough in architectural design. These elements allowed builders to create larger and more durable structures by distributing weight more effectively. The Romans perfected the use of arches and vaults, enabling them to construct massive buildings like the Colosseum and aqueducts that have stood the test of time. The development of the Roman arch paved the way for the construction of expansive public spaces and monumental architecture that influenced future generations. The discovery and utilization of concrete further revolutionized architecture. Ancient Romans were among the first to develop a form of concrete by mixing lime, volcanic ash, and water. This material was incredibly versatile and durable, allowing for the construction of complex structures such as the Pantheon with its massive dome. The use of concrete in Roman architecture provided a foundation for modern construction techniques, enabling architects to experiment with new forms and designs. Gothic architecture, which emerged in the 12th century, introduced several innovations that significantly influenced building design. The development of the pointed arch, ribbed vault, and flying buttress allowed for the construction of taller and more intricate buildings with large stained glass windows. These elements not only enhanced the aesthetic appeal of Gothic cathedrals, but also improved their structural integrity. Iconic structures like Notre Dame de Paris and Chartres Cathedral exemplify the grandeur and technical mastery of Gothic architecture. The Renaissance period marked a revival of classical architectural principles and the integration of artistic expression in building design. Architects like Filippo Brunelleschi and Leon Battista Alberti drew inspiration from ancient Roman and Greek architecture, emphasizing symmetry, proportion, and geometry. Brunelleschi's development of linear perspective revolutionized architectural drawing, allowing for more accurate and realistic representations of buildings. The construction of the Florence Cathedral's dome by Brunelleschi remains a testament to the innovative spirit of Renaissance architecture. The Industrial Revolution brought about significant advancements in materials and construction techniques, transforming architecture once again. The development of iron and steel as building materials enabled the construction of taller and more resilient structures. The Crystal Palace, designed by Joseph Paxton for the Great Exhibition of 1851, showcased the possibilities of iron and glass construction. This pioneering use of prefabricated materials and modular design principles influenced modernist architecture and the development of skyscrapers. The discovery and implementation of reinforced concrete in the late 19th and early 20th centuries marked another milestone in architectural history. Reinforced concrete, which combines concrete with steel reinforcement, offers enhanced strength and flexibility. This material allowed architects like Le Corbusier to explore new forms and create innovative designs, such as the Villa Savoy and the Unite d'Habitation. The versatility of reinforced concrete has made it a staple in modern architecture, enabling the construction of complex and dynamic structures. The advent of skyscrapers in the late 19th century revolutionized urban architecture and city planning. The development of steel frame construction and the invention of the elevator were crucial in making tall buildings feasible. The home insurance building in Chicago, completed in 1885, is often considered the world's first skyscraper. Architects like Louis Sullivan and later, Ludwig Mies van der Rohe and Frank Lloyd Wright further advanced skyscraper design, emphasizing functionalism, simplicity, and the use of modern materials. The Bauhaus movement, founded by Walter Gropius in 1919, played a pivotal role in shaping modern architecture. The Bauhaus school emphasized the integration of art, craft, and technology, promoting functional and minimalist design principles. The movement's influence is evident in the works of architects like Gropius, Mies van der Rohe, and Marcel Breuer. The iconic Bauhaus building in Dessau exemplifies the movement's emphasis on simplicity, functionality, and the use of modern materials. The discovery and application of glass as a prominent architectural material have transformed building design. Innovations in glass manufacturing, such as float glass production, have enabled the creation of large, clear, and strong glass panels. Modernist architects like Ludwig Mies van der Rohe and Philip Johnson utilized glass extensively to create transparent and open spaces. Buildings like the Farnsworth House and the Glass House highlight the aesthetic and functional possibilities of glass in architecture. Sustainable architecture has emerged as a crucial focus in recent decades, driven by the need to address environmental challenges. Discoveries in sustainable materials, energy-efficient technologies, and green building practices have transformed how architects approach design. The incorporation of solar panels, green roofs, and passive heating and cooling systems reduces the environmental impact of buildings. The concept of sustainable architecture is exemplified by structures like the Bullitt Center in Seattle, which aims to be the world's greenest commercial building through its net-zero energy design. Digital technology and computational design have revolutionized architectural practice in the 21st century. The use of computer-aided design and building information modeling allows architects to create precise and detailed digital models of buildings. These tools facilitate collaboration, improve accuracy, and streamline the construction process. Parametric design, enabled by digital technology, allows architects to create complex and adaptive forms that respond to environmental conditions and functional requirements. The discovery and exploration of new materials continue to push the boundaries of architectural design. Innovations such as carbon fiber composites, self-healing concrete, and 3D printed building components offer new possibilities for construction. These materials provide enhanced strength, durability, and flexibility, enabling architects to create structures that were previously unimaginable. The use of 3D printing in architecture, for instance, allows for the rapid and cost-effective construction of complex forms and customized building components. Biomimicry, the practice of drawing inspiration from nature to solve human problems, has also influenced modern architecture. Architects and engineers study natural structures and systems to develop innovative design solutions. Examples of biomimicry in architecture include the Eastgate Center in Zimbabwe, which mimics the cooling system of termite mounds, and the Eden Project in the UK, which uses geodesic domes inspired by natural forms. These designs not only offer functional benefits but also promote a deeper connection between built environments and the natural world. The integration of smart technologies and the Internet of Things has transformed buildings into intelligent environments. Smart buildings utilize sensors, automation systems, and data analytics to optimize energy use, enhance occupant comfort, and improve operational efficiency. Features such as automated lighting, climate control, and security systems can be controlled remotely, providing convenience and energy savings. The development of smart cities, which integrate intelligent infrastructure and sustainable practices, represents the future of urban planning and architecture. The field of adaptive reuse has gained prominence as a sustainable approach to architecture. Adaptive reuse involves repurposing existing buildings for new functions, preserving cultural heritage, while reducing the environmental impact of demolition and new construction. Examples of adaptive reuse include the transformation of old factories into residential lofts, warehouses into office spaces, and churches into community centers. This approach not only conserves resources, but also revitalizes urban areas and maintains architectural diversity. Cultural and contextual considerations have become increasingly important in contemporary architecture. Architects are recognizing the value of designing buildings that respond to local climates, traditions, and social needs. Vernacular architecture, which draws from traditional building techniques and materials, offers valuable lessons in sustainability and resilience. The incorporation of cultural elements in design fosters a sense of identity and belonging, creating spaces that resonate with their users. Resilience in architecture has become a critical focus in response to natural disasters and climate change. Architects are developing designs and materials that enhance the ability of buildings to withstand extreme weather events, earthquakes, and other hazards. Strategies such as elevated structures, flood-resistant materials, and flexible building systems improve the resilience of buildings and communities. The concept of resilient architecture is exemplified by projects like the Big U in New York City, which aims to protect vulnerable areas from flooding through a combination of engineered and natural solutions. Human-centered design has emerged as a guiding principle in modern architecture, emphasizing the importance of creating spaces that prioritize the well-being and comfort of occupants. This approach considers factors such as natural light, indoor air quality, acoustics, and ergonomics in the design process. The incorporation of biophilic design elements, which connect occupants with nature, has been shown to improve mental health and productivity. Human-centered design ensures that buildings are not only functional but also enhance the quality of life for their users. In conclusion, the field of architecture is marked by a rich history of discoveries and innovations that have continually redefined the built environment. From the use of natural materials in ancient structures to the integration of smart technologies in modern buildings, each advancement has contributed to the evolution of architectural practice. As we face new challenges such as climate change, urbanization, and technological advancements, continued research and innovation in architecture will be essential in shaping sustainable, resilient, and human-centered spaces for future generations. The discoveries in architecture not only reflect our technological progress, but also our cultural and social development, highlighting the profound impact of architecture on the human experience. If you enjoyed this video about architecture, please like, share, and subscribe. This helps us to continue making videos like this for everyone.